All right. Sorry about that. I was having some issues with my computer. Word was frozen and it crashed, and it took like almost 10 minutes just to reboot. You can even see it crashed over here. But let's not focus on that. Let us focus on moving forward. So last time we finished 3.8. We had already started that, as well as covered 3.9 and 3.10. So 3.8 and 3.9 were on solving equations. Addition, subtraction, multiplication, and division of both sides. Whatever you see, do the opposite, basically, if you need to move things. Now, of course, if there were like terms or distributions, you would do those. But those are not the only types of equations we're going to see. We're going to see equations known as, in 3.11, proportions. And in 3.12, we're going to study more stuff with proportions, just word problems. So, well, what exactly is a proportion? A proportion states that two ratios or rates are equal. So the word ratio actually sounds a lot like the word rate if you think about it. You probably don't even have to think about it. The first three letters are the same. It's just ratio versus rate. So they are the same thing. A ratio is a rate. A ratio was a fraction. Remember, a fraction is a ratio, is a division. They're all the same thing. So a proportion just states that you have two ratios equal to each other. So what that looks like, that's a ratio. A over B is a ratio. C over D is another ratio. But if I have this ratio equal to that ratio, so an equal sign between them, that is a proportion. That is what a proportion looks like. It's a fraction equal to a fraction. And there is a very simple way to solve these and to check them. But we'll get into that in a little bit. So let's try out a couple of these. We're not going to do all four of these. Let's start with one. Write a proportion for each statement. So again, the whole goal is just write a fraction equal to a fraction, but do things in the order that you see. So when you see 7 is to 8, 7 is to 8 means that that's one of the fractions. It should be 7 over 8. So the is to means that the first is the top, the second's the bottom. When we see as, this tends to mean our equal sign. And it's kind of weird because you may have heard me say before that is means equals, but there's two of them and you can't have two equals in an equation, at least not at our level. And it's the fact that it's not just is, it says is to. That's what makes it different than an equals. So then we have the 21 is to 24. So that's our other fraction. 7 is to 8. That's the first one. 21 is to 24. And then we have the equals between them. 7 is to 8, so 7/8 is the same as 21 is to 24, 21/24. And the cool thing is, if you actually reduced this right fraction, it would be the left fraction. 3 goes into 21 7 times, 3 goes into 24 8 times. So you can see that these are the same thing, just by reduction. But it's not always that obvious. And when we go and try and build a proportion, it's not guaranteed that it actually works. Now, when we're told it is, it should work, but we may have to ask ourselves, is this a proportion? Or we may have to check something. So let's try out number 2. $120 per day, so per also means fraction, so that's our fraction bar right there, is proportional, so that's just another way of saying is equal to another fraction of $600 per 5 days. So again, the per is our fraction. So $120 per day. Now there's no number there, so it's 1. Is proportional, means equals, and then $600 per 5 days, so the 600 goes on top, and the 5 goes on the bottom. Another nice thing about proportions is that the unit should be consistent. For this number 2, it was dollars in the top of each of these, $120, $600, and it was days in the bottom of these, per 1 day, per 5 days. This is always true in proportions. You have to be consistent with your units. And if you take me with quantitative reasoning or any other good teacher for QR, they would really emphasize that for setting up proportions. All right, let's do number 3 and then we'll move on. 3 ounces is to, well, I might have to sneeze. Hold on. I don't want to blow your. Sorry about that. Then I had to blow my nose. Didn't want to have a disaster. Okay, so 3 ounces is to 0.1875 pounds, as 15 ounces is to 0.9375 pounds. So you can even help yourself. And this is what I do with my QR students. I say, write out units so that you make sure everything goes in the right place. So ounces is the first thing, pounds is the second thing. So ounces over pounds. You can hear I'm stuffed up. All right, so the first fraction, 3 is to 0.1875, so 3 ounces over 0.1875 pounds. Then our equals. So is to blah, blah, blah as, so that's the equals, 15, and that's an ounce, so top, 0.9375 pounds in the bottom. Number 4 would be 75 over 3 equals 200 over 8, just FYI. But let's move on. So that's how we can set up a proportion. And when we're dealing with word problems, this is more often what we have to do is actually build that proportion. Okay, but the rest of the section follows on, is all about checking them or solving them. And both of them involve the same idea, and that's to cross multiply. So cross multiply, they say cross product, that's the same thing as cross multiply. So what we do is we cross multiply. So they say if you have a fraction a over b equal to another fraction c over d, now these are generally numbers, or at least 3 of the 4 will have to be numbers. What you can do is take the a times the d, that's what this says, and set it equal to the b times the c, and that's what this says. Now, there's some reasons algebraically this works. Basically, you're just multiplying both sides by b, and then multiplying both sides by d. Some things cancel, some things don't, and you end up with this. So, in my own letters, let's start with black, actually. A over b equals c over d. This is what it means to cross multiply. We take the a, and we multiply it by the d. So a times d, and then we set it equal to, and then we take the b and we multiply it by the c. That's why we call it a cross product, because we're taking the top of one times the bottom of the other. So that's equal to b times c. Again, it's literally the same thing they have. I'm just showing you how it's developed. So cross multiplication is an awesome technique for solving proportions. It's an awesome technique for solving a fraction equal to a fraction. Cross multiplying is not used for adding or subtracting fractions. Cross multiplying is not used for multiplying or dividing fractions. So many students, when they're introduced to cross multiplication, they want to cross multiply everything. And it really does not get used that much, honestly. It gets used when you have a fraction equal to a fraction. So they ask us to determine whether the ratios form a proportion. So if 14/15 is the same thing as 28/30, that means if you cross multiply them, whatever products you get on each side should be the same. So to check, we just cross multiply and see if they match. CM means cross multiply and see if they match. That's all you have to do. It's not a lot of work. Okay, so for 5, we're going to take the 14 times the 30. The 14 and the 30 get multiplied. And then we're going to set that equal, and we're wondering if this is true, so I'm going to put a little question mark over that. And then we take that 15 times the 28. Or you can write the 28 first. You can write the 15 and the 28 on the left of the equals, the 14 and the 30 on the right of the equals. It's not going to matter as long as you're taking a top times its opposite bottom. All right, so 14 times 30, 14 times 3 is 42. So that should be 420. Is that equal to 15 times 28? That's 20, so 280 plus 140, and that is 420. 420 is 420. So yes, these are a proportion. Or this is a proportion. These ratios set equal to each other form a proportion. All right, so let's try out 6. So what some people recognize as 5 is, hey, if I divide 28 and 30 by 2, I'll get 14/15. That's the same fraction. That is actually another way to check, and if that's how you do it, that's fine, as long as you get the answer right. And then what some people might say, oh, okay, well, 8 and 9, well, 16, 8 goes into that, 9 goes into 27, so this is definitely a proportion. I'd hold your horses on that, though. Be very, very careful when you start trying to rush and make assumptions. Let's cross multiply and see what happens, or reduce both and see what happens. That's the other way of doing it. So we take the 8 times the 27, and we say, is that the same thing as the 9 times the 16? 8 times 27, what's that, 216? And then 9 times 16, that's 90 and 54, so that's 144. Now last time, 420, 420, those are the same. Yes, proportion. 216, 144, no, those are not the same. That's not an X, that's me saying no. Check yes, X no. Very, very easy, especially considering the fact that you are allowed calculators to do your arithmetic at this point. You should still be able to do these calculations without a calculator though. All right, number 7. We got negative 0.75 over 18 is equal to negative 0.25 over 6. So we're going to cross multiply. Now, some people will say, hey, you're not supposed to have decimals and fractions. Let's move that decimal right twice and then do the same to the bottom, same here, same to the bottom. Yeah, you can, but you're not going to have to because we're just going to do arithmetic here. We're not worried about the particular fractions. We're going to make them go away in a hot second. So we take the negative 0.75, don't forget the sign, times the 6. So that's the top left times the bottom right. We're saying, is that the same as the 18 times the negative 0.25? So 0.75 times 6 is 4.5. A negative times a positive, those are opposites, so negative. We're saying, is that the same as? And then 18 times 0.25 is going to be 4.5. And a positive times a negative is a negative. And we have negative 4.5, negative 4.5, so yes. Those are proportional. Number 8, for good measure, negative 18 times the negative 2 1/3. So that's taking the negative 18 times the negative 2 1/3. We're saying, is that equal to the 3 times the 14? Well, 3 times 14 is going to be 42. And this negative times this negative, those are the same sign, so it's going to make a positive. But we don't know how to multiply 2 1/3 times anything. We have to convert to an improper fraction. 2 times 3 is 6, plus 1 is 7. So that's, I'm just going to ignore the signs now since they'll cancel. 18 times 7 1/3. 3 will go into 18 6 times. So that's a 1 and a 6 now. And 6 times 7 is 42. So we end up with 42 equals 42, question mark. Yes, that works. So they are proportionals. They are proportions, they are proportional. It is a proportion, however you want to say it. 9 and 10 are pretty much the same thing, so I'm going to skip those in the interest of moving on. Solving proportions. Literally the same exact technique as what we were just doing to start it. The condition to be able to solve a proportion is that 3 of the 4 values have to be known. So it can't be A over B equals C over D. 3 of those have to be numbers. The 4th is going to be your unknown, your variable, your X, your Y, your A, whatever. And we'll be able to solve that by cross multiplying. Let's set the cross products equal to each other. And less mechanical, less wordy, cross multiply. Solve, which means, well, you'll have one more step to solve it and you'll see it. It's the same step every single time. Step 3, check, that's optional. Remember, the better you are, the less likely you need to check. But I'm not saying that's a guarantee. If you always want to check, then always check. If you never want to check, I hope you're right. That's all I can say. Okay, so cross multiply, the same thing we were doing in the last set of problems. Cross multiply, but it's not just going to be a number equal to a number that may or may not match. You're going to get something like 5x equals 20 at this point that you'll have to divide both sides in that particular problem by 5. It's just dividing by whatever number the x is paired with. So 11 and 12 are, again, honestly, just more of the same. I'll do 11, but not 12. They say determine whether the given value is a solution to the proportion. So instead of writing x, they tell us to write 3. So that's 5 over 3 equals 12 over 8. And we should use the question mark since we're not sure. We cross multiply. I'm going to run out of room. So 5 times 8, is that the same as the 3 times the 12? 5 times 8 is 40. 3 times 12 is 36. And that's a big fat no. 3 is not the solution. Let's do 12. We got time. We got time. So we're saying 3 over 8.4, is that equal to 2.5 over 7? Cross multiplying, that's what this double arrow is saying to do. Again, lack of space. We take the 3 times the 7, we say, is that the same as the 8.4 times the 2.5? Well, 3 times 7 is 21. 8.4 times 2.5. Let's see. That's 21. Those are the same. So yes, x equals 2.5 is a solution. Again, we didn't find the solution. We were told what it may or may not be and asked to check it. So we checked it. Boring, more of the same. Let's move on. Let's actually try solving some proportions. And they say be sure to check. I'm going to leave that up to you. I'll check one of them. I'll check the first one, but not the rest. Hold on, let me cough. All right, so 13 over 8 equals 39 over y. So we have 1, 2, 3 numbers and 1 variable. This is the condition to be able to solve. If there were 2 variables, if this 8 was, say, x, this would not be solvable. We are only allowed to have 1 variable in order to solve an equation at our level. So cross multiply. Take the 13 times the y, that's the top left times the bottom right, and set that equal to the 8 times the 39. You don't really need the dot between the 13 and the y. Some people put it, some people don't. It's up to you. I prefer it without. And then 8 times 39, let's see. 8 times 40 would be 320, so that's 1 less 8, so that's 312. I know I multiply weird. So we got 13y equals 312. We just learned how to solve this type of equation last class. And actually, we learned how to do this in chapter 2 as well. I mentioned that going forward. You just divide both sides by the number with the variable. That's 13 times y. To get rid of 13 times, you divide. So that the 13s cancel, leaving us with just the y. And then 312 divided by 13, that's 20 is 260, 52 is another 4, so 24. So 24 is our solution, but I'm going to check it. Again, I said I'd check one of them. So we're going to replace the y with 24. So 13 over 8, is that equal to 39 over 24? Cross multiply, you get 13 times 24. Is that equal to 8 times 39? Well, we already know the 8 times 39 is 312. Let's see, 1324, so that's 240, plus another 72, that's 312. That works. So y equals 24 is definitely the solution. All right, 14. X over 7 equals 25 over 14. And the beautiful thing about these proportions is it doesn't matter where the variable is. This one was in the bottom right, this one's in the top left, the next one's bottom right, the next one's bottom right. They could have been bottom left, top right, it doesn't matter. As long as only one of these is a variable. We cross multiply. Take the x times the 14. Set that equal to the 7 times the 25. I don't like having the variable first, so let's write that as 14 times x, aka just 14x. 7 quarters would be 175 cents, so 7 times 25 is 175. Again, I know I multiply weird. It is what it is. I like context. That says 14 times x equals 175, so we divide both sides by the 14. Remember, I don't care what that 175 is for this problem. And you could take the time and do that by hand. It might take you a few minutes. 175 divided by 14, that's going to be 12 and a half. It checks. Please feel free to check it. Number 15. Again, cross multiply. Oh, let me switch back to red. So we take the 9 times the a, and that should be equal to the 20 times the 0.27. 9 times a is 9a. 27 times 2 is 54. And then we got 1, 2, so 5.4 should be the answer for that right side. It's because 2 decimals and then 1 that would undo at 20. It's not actually 2. Then we divide both sides by 9 to finish this. Those are 9s in black, not a's. So we get a equals, and then 5.4 divided by 9. Well, 54 divided by 9 is 6, so that would be 0.6. Again, you can check it if you want. I'm not going to always show that work. Finally, we got 16. This will be the most annoying one because mixed numbers always annoy us when we have to multiply or divide them. So we're going to cross multiply. We take the 4 times the m. We set it equal to the 10 times the 1 3/5, which we'll have to convert. We still have no clue how to multiply mixed numbers. I still have no clue how to multiply mixed numbers. I'm not even lying. I can do some of them in my head because I just can, but I can't do them all. And I'm not even going to explain how I can do some. So that's 1 times 5 is 5, plus 3 is 8. So that's 10 times 8 over 5. 5 will go into 10 twice, so let's reduce that. 5 goes into 5 once and into 10 twice. So this is now, I'm going to run out of room. Let me go over here. 4m is equal to, so again, the 5 went into 10 twice, 2 times 8 is 16. Or you can say 10 times 8 is 80, divided by 5 is 16. Divide both sides by 4, so that those cancel, and we get our answer that m is 4. Please feel free to check. It will check, I promise you. Because the right side, the 10 times the 1 3/5 was 10 times 8/5, which was 16. When you cross multiply the 4 and the 4, 4 times 4 is 16. Again, it does check out. And that's 311. There's nothing too crazy in this section. Please make sure you're taking the time and doing these examples on your own. Make sure you're doing the homework. Again, I've still got so many students who are just not doing anything. I'm about to send out another email saying, you need to get with the program. Some of you are keeping up with the homeworks and the quizzes, but you haven't taken test 2. I've got several students in chapter 3 homework that have not taken either of test 2 parts, or have taken part A but not part B. Please do not wait. Get that done sooner than later so that you don't forget anything. Also remember, if you take your 2 attempts and need a 3rd or a 4th, I will give you those if you email me and let me know. All right. So 311's out. Let's do 312. Proportions, and problem solving. There is literally nothing new in this section. I love sections like that because we can just dive headfirst into everything. Now you might say, well, yeah, there is something new, Mr. Beckner. You're giving us word problems with proportions. Yeah, but I've given you word problems before. I've given you things that you had to interpret into sentences and set something up. So I'd argue that this isn't new. It just combines that idea with the idea of proportions. It's more like mixing 2 ingredients. So what you need to do with these problems, is set up a proportion, then solve by cross multiplying. Check if desired. It is helpful to use, sorry, let me not say use your words. Let me say make a fraction of units for consistency. That thing I mentioned in the last section, I suggest my QR class do, use their words. What that means is set up a fraction with the units, write apples over oranges, or students over teachers, or meters over seconds, hint, wink, nudge for number 1. So before you go start trying to write your fraction equal to a fraction, just write one single fraction to the side in words and write the 2 units. Because there's this cool fact with proportions. You can set these things up arguably 16 different ways. Some people say 8, some people say 16, I say 16. You can set these up a ton of ways is the point and get the right answer, but you can also set it up a ton of ways and get the wrong answer. So a lot of teachers will say you need to go in order. Since they said 300 meters and then 264 seconds, you have to write the 300 over the 264 first and then keep going. That's kind of a lie. You don't have to write 300 over 264. You could write 264 over 300 as long as you're consistent with the units. So again, I'm going to undo all that and I'll show you my more quantitative approach. So instead of just trying to go 300 over 264, blah, 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 and then say, well, where does the 660 go? Top, bottom? Some people always assume top, but sometimes it's the bottom. The units are the hint. So I see meters, I see seconds. So those are the units I'll write as a fraction. I can write meters over seconds, or I can write seconds over meters. In fact, I'll do this problem twice. I'll do it both ways to show you I'm not lying. So the first attempt, for attempt A, we'll go meters over seconds. So Lewis swam 300 meters in 264 seconds. The numbers that are paired together in a sentence like that go together as a fraction. So that's 300 over 264, then equal. And that's going to be another fraction. At this rate, how many meters can Lewis swim in 660 seconds? Again, the units of the isolated number that doesn't have a pair, that's our clue as to where to put this. Where should the 660 go, the top or the bottom? Well, we said we're putting all seconds values in the bottom, so the 660 has to go in the bottom this way, making our x go in the top. So now we're going to cross multiply. We'll take the 300 times the 660. We'll set that equal to the 264 times the x. Again, top left times bottom right, bottom left times top right. Let's see, 3 times 66 would be 198, then tack on 1, 2, 3 zeros. So that's 198,000. I'll put a comma. Equals the 264x. Divide both sides. Again, I don't even care what this number is right now. I'm only looking at the 264x. That tells me what to do. That says divide both sides by 264. And if you do that division, you definitely want to use a calculator for that. In the interest of time, that'll give us x equals 750. Now, in my quantitative reasoning class, I would not give full credit for that answer because units are important. In Connect, you don't really have to type units. You might have to use a drag down menu every now and then. So that's good enough for us, arguably, but you still want to be quantitative. You want to have a good understanding of this. And if I said seconds a second ago, that may or may not be right. I need to actually go back and say, all right, where was the x? X was in a top. See, the x was in a top, and what goes in top? Meters. So this is 750 meters. Again, I don't know if I said seconds previously or not. I may have, but I did not mean to. I was just talking too fast. So how many meters can Lewis swim in 660 seconds? He can swim 750 meters. You would not answer 750 seconds because the question was how many meters? It's another clue. Really loud airplane over my house right now. Okay, so that was method A. Let's try this another way. So instead of doing meters over seconds, let's buck the trend. Buck. Make sure that I said that right. Seconds over meters. It is much more common and desired to do meters over seconds because that's the order they gave us things, meters, then seconds. That's the way a lot of teachers will argue you're supposed to do it. But again, I'm more about if something works, it works. So let's just be consistent. Always write the seconds in the top, always write meters in the bottom. So the first sentence, the 300 meters in 264 seconds, now this is flip-flopped. And I know why teachers don't want to teach you this way is because someone's just going to instinctively write the 300 over the 264 because they're rushing. But no, the 264 was a second, so it goes in the top. The 300 was a meter, so it goes in the bottom. Equals, how many meters can Lewis swim in 660 seconds? Since that's a seconds, we said all seconds go in the top. So the 660 goes in the top, x in the bottom. We're going to cross multiply. So we'll take the 264 times the x, the 300 times the 660, literally the exact same thing, except the left side's now the right side. That's why I said there's like 16 different ways to set this up and still get the right answer. But there's also a ton of ways to set it up incorrectly and get the wrong answer. So you get 264x equals 198,000. You're going to divide by 264 once again. And no surprise, you end up with x equals 750. The same answer. So as long as you're consistent, as long as you pay attention, as long as you don't rush, lots of ways to get this right. You don't have to write the 264 and the 300 on the left side. You can write it on the right side. You don't actually have to write seconds over meters. There is another way to set up this proportion using different words that I will not describe because I don't want to confuse you and still ultimately get this right. That's why there's so many ways to get this right. But again, for every right way, there is a wrong way. All right, let's try another, and we'll just do it one way from now on, and I will do it in the order seen, just to kind of go with that flow. But again, if you prefer, you can buck with a B, the trend. You can do the second thing over the first thing as long as you're consistent. All right, number 2, the euro with that funky little symbol is the money used in most European countries. If the exchange rate is 3 euros, will get you $4 with no fee. How many euros would you exchange for $780? So we got a European, and we know he wants $780 for his American trip. But he needs to know how many euros does he need to bring to get that $780. Or maybe you're just saying you've got an American with $780 and he's exchanging and he wants to know how many euros he's getting. That sounds a little more probabilistic. So what are the 2 different things we're talking about? Euro, money used, European countries, exchange rate. Here we go. 3 euros is $4. So our exchange, and you can use symbols or words. You can write EUROS over bucks or dollars. Or you can write the symbol, which kind of looks like a weird E over a dollar symbol. And again, you could go dollars over euros if you wanted, but I'm not going to do this every time. Let's just go euros over dollars. So the exchange rate is 3 will get you 4. 3 euros get you $4. So the 3 is a euro, so it has to go in the top. The 4 is a dollar, so it has to go in the bottom. Okay. So that was the completed scenario. Now we're wondering, how many euros do we get for $780? Well, the 780 is a dollar, so it has to go on the bottom, not the top, making our X. You could write E, you could write whatever letter you like. Goes in the top right. You're going to cross multiply. So we take the 3 times the 780, and we set that equal to the 4 times the X. Uh, 78 times 3 is 234, tack on a 0, so that's 2,340 is equal to 4x. And then we solve this. Again, we don't care what the 2340 is to tell us what to do. It's just the 4 times the x tells us divide both sides by 4. Come on, undo. I must have lifted my pen. All right. So 4 will go into 23 5 times, and a 34 8 times, and a 25 times, so that's 585. That's our unknown. This is not a good answer quantitatively. How many euros would you exchange? This is supposed to be the euros. So it's that funny looking CE thing. 585 euros would get you $780. Or vice versa, if you're not paying an exchange fee. That might be the worst euro symbol I've ever written. There we go. That's a little better. All right, number 3. 3 pounds of fresh cod fish costs $12.75. How much would 8 pounds cost? I tell you what, this right here is an amazing example of a proportion that you can use in your real life when you're going to the grocery store. Oh, this thing costs $5.95 a pound. I need 2.5 pounds. How much is that going to cost me? Set up a proportion, cross multiply and solve it. There you go. Now, if you have the per pound value, spoilers, all you really have to do is take the weight times the per pound number, but it still works either way. So 3 pounds of fish cost $12.75. So what are the 2 things we're talking about? You could write fish and money. You could write pounds and dollars. I'll go in the order seen. We saw fish before money. Or you could write it as pounds, LBS over dollar symbol. There's a dozen different ways you can write this, probably more than that, as long as you understand the order. You're writing this. I'm not grading you on that. So the 3 pounds goes for $12.75. 3 is the fish or the pounds, so that goes in the top over 1275 is the money, or the dollars, so that goes in the bottom, equals another fraction. Now the 8 pounds, that's a pounds. The pounds are the amount of fish, or what goes in the top, so the 8 goes in the top, making the x the bottom. Then we're going to cross multiply, which says we take the 3 times the x, set that equal to the 12.75 times the 8. The order of the products never matter. X times 3, 8 times 1275, same thing. All right, so that's just 3x. We don't need the dot really. Equals 96 plus, okay, that's going to be 102. And then we divide both sides by 3. Three would go into 90 30 times. That's another 12, so that's 4, so 34. Right? No. Keeping you on your toes. 34 is the numerical answer. But we're supposed to relate this to the units. How much does it cost? This 34, that X was in the bottom, that's money, that's dollars. So it's 34 bucks, $34. Remember, like I said, in the real world, units are critical. Critical, critical, critical. All right, let's do another. I think they only have 5 problems in this section, so we're going to knock them all out. Let me give myself a little space. There we go. The dimensions of Greg's original photo are proportional to the enlarged copy of the photo. This is generally true. When you get a bigger or smaller picture, we like those dimensions, the length and the width, to be proportional so that the photo doesn't look stretched out or widened or flattened or whatever other word to say, disformed. Weird looking. In other words, if you want to double the width, you got to double the length, basically. All right, so the original photo has a length of 9 inches and a width of 16 inches. If the new photo has a width of 24 inches, what is the length? Now be careful when you're writing your words to the side to remind you what goes top and bottom. Some people might think, oh, well, this is inches, so let me write inches over inches. They're the same thing. How do I know where the 9 and the 16 should go? How do I know where the 24 should go in relation to that? So that's not very descriptive because the units are the same thing. So I would not want to do it that way. Make sure you're using different words. So what do we have? Photo, well, they're both photos. That's not going to work. Length and width. And they went length before width, so I'll keep that as L over W. Length over width. Spell it out if you want to. So the original photo has a length of 9, so that goes in the top, 9 inches, and a width of 16, so that goes in the bottom. Set it equal to. The new photo, the next scenario, has a width of 24. The width is 24. Is that top or bottom? Top or bottom? It's the bottom. So the 24 goes in the bottom. Don't rush and just always put your variable in the top. It might go in the bottom. We're going to cross multiply. Take the 9 times the 24. Set that equal to the 16 times the x. All right, 9 times 24, well, 9 times 20 is 180, 9 times 4 is 36. Add those, you get 216, equals 16x. Then we're going to divide both sides by 16 so that they cancel. And the 216 divided by 16, that's 13 and some change. Is it 13 and a half? Yes, it is. Again, calculators are allowed. Because I'm not using one doesn't mean you don't have to. But this is still something you should be capable of without a calculator. The calculator's here just to save us time because we had so much other stuff to do to set it up. Again, I don't really like that as an answer. In real world, if I was giving you a paper pencil test, wasn't multiple choice, you didn't write the units, I would not give you full credit. So this was supposed to be the length. So it's 13.5 inches, but the width and the length were in the same units. So I don't feel like this is descriptive enough. I would like to attach that the length is 13.5 inches in the answer to make sure I am clear and concise. Okay, last one. And this will be the last problem of the day. I don't want to get too ahead. We only have 2 sections left over, so we'll cover them next time. So 8 flats of flowers covers 90 square feet. 90 square feet, that's an area. I know it's an area because it's in square units. And we'll get into that shortly. You could use the word cover instead if you don't know that 90 square feet of area is area. Then they ask us how many flats of flowers would cover 157.5 square feet rounded to the nearest whole unit. So they're saying the answer's probably going to be a decimal and we're going to round it. Okay, so 8 flats, that's definitely the first one. And they're going to cover 90 square feet. So someone might write square feet, or you might write flats over the feet squared with the units, or you could write flats over area, or you can write flowers over any of those 3 things. I think flats over area is the most descriptive, so that's the one I would personally write. But again, as long as you use words that help you associate tops and bottoms correctly, nobody cares. 8 flats covers 90 square feet. So the 8 is a flat, that goes in the top. I believe a flat is like when when you buy like those little cartons of flowers and they come 4 or 6 to a pack usually. Not necessarily that number. Don't quote me on that. I'm not much of a gardener. And it covers 90 square feet. So that's the area or the square feet or the feet squared, whichever way you wrote it. So that's 8 over 90 equals. How many flats would cover 157.5 square feet? So this 157.5 is an area or it's in square feet. We said that goes in the bottom. 157.5, meaning the x is the flats. That's our unknown. We're going to cross multiply. So we'll take the 8 times 157.5, and I will pull out a calculator for that one, equals the 90 times the x. Let me get that. 8 times 157.5, that's 1260, equals 90x. We don't care what the 1260 is, we care what the 90 times x is, because that tells us what to divide by. Divide both sides by 90. You can cancel out a factor of 10. 1 plus 2 is 3, plus 6 is 9. So that's divisible by 3, not necessarily by 9 though. Either way, let's just do the division. It is 14, it is a whole number. Oops, wrong color. And I'll write it here. So 14 is equal to x. That meant 32. No, 42. Yep, 42, and 42 is divisible by 3. Yep, that works. So 14 is what? It's flats. So 14 flats. That's funny. They told us to round to the nearest whole, but you didn't actually have to round. Very unusual for Connect. But it's just keeping you on your toes. So once again, today we covered proportions. What are proportions? It's a ratio equal to a ratio. The whole idea of solving or checking proportions is one simple concept of cross multiplying. When we got to the word problems, the only complication here was understanding how to set it up, making sure the number's in the right place. And I did say that there's 8, arguably 16 different ways to set every single one of these up correctly and get the right answer. But there's also as many wrong setups with wrong answers, which is why I'm suggesting to use your words, as our parents teach us when we're young, ha ha ha. so that you can be consistent. So we're going to call it a day here. We have finished 311 and 312, so those will be due next class. I had given you a short extension on 3.8, as well as 9 and 10. If you got the, no, it was 3.8 that got the extension because of the, we didn't finish it with 3.7. That's what it was. So again, all your due dates after I post this video will be accurate and Connect. So for my Monday, Wednesday class, I want to say 3.9 and 3.10 are due Monday. I think it's also for my Tuesday, Thursday, yes, because I couldn't post the video on time because of my power outage. That's what it was. That's what I was thinking of. So for everybody, 3, 8, 9, and 10, that's due Monday. 3, 11, and 12 would be due the class after. So again, due dates will be posted and Connect accurately. Besides that, have a good day. Make sure you're watching these videos. Make sure you're doing your homework. And I just realized that if you're not watching the video, me saying watch the video is pointless. Haha. But please, 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 please stay at a pace with this course. We are almost done. We've only got a couple weeks left. So that final exam is coming around the bend, but only if you are ready for it. Have a good day.